Scientific notation, fun for the whole family. Exhibit A. Scientific notation. Now, we have, I'm going to write this right here, in scientific notation. But we're going to go from scientific notation to standard form. So, if they give you 3.6 times 10, 3.2 times 10 to the 6th power, this power right here tells you how many places to move the decimal. Now, if you think in your head 10 to the 2nd power, how much is that?
20. 200. 1,000.
10 to the 2nd power.
1,000.
10 times 10
is 100.
What?
10 to the 2nd power. Okay, 10 to the 2nd power is 100. So 10 to the 6th is going to be way bigger than that. So, do you think I need to move this decimal just reasonably thinking? Do I need to move it to the left or to the right? The right. I got to move it how many places?
6.
So let's go. Let's do that.
1.
1. Add some zeros. 2, 3, 4, 5, 6. Okay. Shh. So 3, 2 with 5 zeros.
Oh, yeah.
So the answer, 1.
It's 3,200,000.
Thank you. Thank you.
Yeah.
You redeemed yourself a little bit there. All right, 3,200,000.
That's it. Is that all
Oh no, we got a lot harder than that. Exhibit B. .8 times 10 to the -3rd power. Now, first of all, you need to know scientific notation is always a number 1 through 9 and then decimal. Okay? So to be in scientific form, it has to be, this first number has to be 1 through 9, then the decimal. It can't be 0 and it can't be 98 point something. It's a number, decimal, and whatever. It can be more numbers afterwards.
Does it have to be 10?
And it always has to be 10 to some power. Okay. Shamil,
Welcome back.
welcome back. All right, now. -3 power. So which way do you think I'm moving the
Oh,
decimal?
it's going left.
Gonna go left. This number is gonna be small. It's gonna be less than 1. So it's gonna be 1, add a 0, 2, 3.
Three double zero.
So I got decimal 0, 0, 9, 8.
That was so good.
Shh.
Right example.
One.
And both of them.
Exhibit C. Exhibit.
It's examples. That's what I always thought it was.
That's what I want you to believe. 2, 4, 7. Ooh, craziness.
You made it up.
4.247. Now, is this in scientific notation?
Yeah.
Yes, because it has a number, 1 through 9, then the decimal, so it's good. It can have as many numbers after the decimal it wants to. And it's 10 to some power. But 10 to the 0 power, what is
Zero.
We'll go into that in a second. We're gonna do, first of all, let's just write this number down. And let's move it. The place values, it tells me to move it. How many places does it tell you to move?
None.
Okay, so there's your answer. Yay, math. But now listen. Also, know anything to the 0 power is what, Ava? Anything to the 0 power is what? No.
Zero.
Is 1. So if I said 25 to the 0 power, what is that?
25.
1.
Sorry.
If I said 10 to the 0 power is what?
10.
1.
Sorry.
If I said 72 to the 0 power, what is it? 1. If I said x to the 0 power, what is that? 1. So 4.247 times 1 is what?
1. So move it over 1.
4.
You told us it was 1.
4.247 times 1 is what?
2.4.
So there you go. So you should know that's 1, and then you know I ain't got to move the decimal anywhere.
What are you looking at?
Where's the heat?
Okay, I need y'all to be quiet. Now we're going to go to, we're going to give it standard form, the number we're used to seeing. And we're going to put this in scientific notation. We're going to put it in scientific notation. So where does the decimal need to be in scientific notation? In between what two numbers?
No. 9 and 7.
9 and 7, right. It needs to be between 9 and 7 because it needs to be a number, then a decimal.
But that changes.
So let's get this comma out of the way. So where's the decimal right now?
At the end, 9
At the-
0.
Where's it now?
No, it's not. It's behind the 0, guys.
The decimal now is right here. I need it right here. So I need to move it, and while I move it, I need to count it.
3.
1, 2, 3.
-3.
Hold on. It's 9.75. I don't need the 0. Times 10. Here's the question you need to ask yourself. This is what gets confusing. It gets easy when you do one of these. When you say, oh, positive, I go to the right. Negative, I go to the left. But this time I went to the left, right?
But you're going to make it positive.
But I'll make it positive. Now here's the thing you need to know. Is this number, 9,750, is it greater than 1?
Yes.
So if it's greater than 1, make it a positive power. If it's great, I don't care what it is. If it's greater than 1, make it a positive power. We counting how many places?
3.
So there's your power.
Oh, yeah.
There is your power. Okay, last exhibit here. E. Decimal 0, 4, 5, 6. We need to put this in scientific notation. Where does the decimal need to be between? The 4 and the 5, because we cannot have a 0. We got the first number has to be 1 through 9. Can't be a 0. So we need the decimal to be here, between 4 and 5. And right now it's here. So how many places do I need to move it to get it where I need it?
2.
1, 2. So it's 4.56 times 10. Now, was that number to begin with, was it greater than 1 or less than 1?
Less than.
Less than 1. Less than 1, so the power is going to be a negative. So I move it 2 places, it's negative 2. We having fun?
Yeah. Totally. Yeah, man. When do we leave? Yay.
Never.
Can we do one more? Because we keep forgetting the F and leaving it out.
Okay, I'm going to do one more because somebody want to do exhibit F.
No.
Who did that? He keeps
Who
leaving
said
the
that?
F out. Great.
Shh. Let's calm down, let's calm down. let's go with something crazy
We
here.
haven't done F yet.
Exactly, that's why she wanted to do it.
Who wanted to do it?
10,526.
I never did.
10,526. Alright, Bella, what is the decimal right now? There's not one we see visually, so what do you think it is? Behind the six, perfect. Now, what, in between, what two numbers do we need the decimal? Anyone? 1 and 0, perfect. So I need to move it back 1, 2, 3, 4 places. 1.0526 times 10. 1, 2, 3, 4. Is it negative 4 or positive 4? Positive 4, because that number is higher than 1.
Wait, did you say in between 1 and 5 or 1?
Always one number, then the next. One number, then the next decimal.